I would just encourage people to, especially people that are working for big companies, to actually do their own in-house research. I just feel that there is so much that could still be done. There is so much that still requires doing. Yeah, I just feel that there's a lot that can be done, a lot that should be done. And when they've done those results and when they've done those tests, bring them to the conference.
Today I'm speaking with Dick Minnitt. Dick is a professor emeritus at the Wits University in South Africa, and he is really deep into the world of sampling. He's actually involved with organizing the next sampling conference held in Joburg. So who better to speak to about all things sampling? So obviously I've spoken with Jeff Lyman on the channel before, and there's much to say about the world of sampling, and there were some clarifications needed out of that talk. So I dive into some of those subjects. I asked Dick about, is the sampling world winning? Are we conquering our problems, and are we coming up with solutions? And obviously I do go down some of the rabbit holes on some of the intricacies of heterogeneity tests, one of my favorite subjects. And Dick's got some really interesting papers out of that you should read, absolute classics, and ask him to explain those a little bit further. We also talk about a paper that he did in 2021 or 22, which is, that famous problem in the lab when we stand there as consultants, talk about the grouping and segregation error in the pulp as it lies on the bench, as they put the corners of the sheet towards each other to homogenize the sample. Fascinating outcome. I wasn't quite aware of this work until recently. So we dive into a bit of that. And then we obviously talk about other things sampling, and we circle back to some work that he's doing with Scott Automation, the people who make the Boyd equipment, the crushers and the splitters. And he's doing some work at the moment that he's talking about. Really interesting to hear about the accuracy of the splitting, particularly when it is about creating that perfect 300 gram material for the photon chrysos cup that they use in there. You don't want to just pour it into a cup. You need an accurate split, and that's the work that he's been working on. So we go into a bit of detail as well to make it current. So there's a lot in there in an hour. I hope you enjoy. Let's get into it. Hey, Dick, how you been?
Very good, very good.
Hey, long time no see. It's been a while. I think last time we saw each other was at a sampling conference. I don't know which one, but was it the Perth one? But I was going back through my notes, and I remember meeting you, I believe, at one of Francis Bittard's sampling courses, 5 days of sampling in Johannesburg. So where you were as well with some of your students. So you're very kind to show me some around Joburg, and really appreciated your company at the time. But to tell us what you've been up to. I mean, we haven't spoken for such a long time.
Yeah, true. Okay, so I retired at the end of 2017. So I was a professor in the School of Mining Engineering at Wits University, and I taught subjects to postgraduate students in mineral economics, minerals marketing, the theory and practice of sampling. I currently teach a course in conditional simulation as well. So I've been busy. Although I retired in 2017, I'm still very much involved with the School of Mining Engineering. They keep me on as a visiting emeritus professor, so for which I'm very thankful. I found retirement quite a challenge, and just being able to keep yourself occupied was a big plus for me. I really was thankful for the fact that we could have this ongoing relationship with the School of Mining Engineering. So at the moment, I still do the lecturing, as I say, and I'm involved in a considerable amount of consulting work, which also keeps me busy.
So just definitely keeping busy. That's so retirement it's not really it sounds great, but you're still out there. Fantastic. Well, so with the work, because conditional simulation, and I knew you were sort of into that space as well, but we know each other more from a sampling perspective.
Yes.
And
yes.
So And that's one of the things I wanted to talk to you about here, because I've been a little bit out of touch. But you probably know we had Jeff Lyman on the call here a few months ago, and that certainly, sort of stirred the pot a little bit in a few areas. And I'm not on the inside of the walls of the sampling grades, and I only try to follow the papers out there. And I'll come back to one of a favorite paper of yours that I always take with me on all the work that I do. But so that sampling space is interesting. And how do you, maybe just to start in there, how do you still actively contribute to those conferences? And do you feel that we're, to get straight into, do you feel that we're moving forward in this sampling space? I mean, you've retired from this, but you've put a whole bunch of papers out. Do you feel like satisfied that that we solved the puzzle, or do you feel a little bit of, is there's more to do there? How would you capture that?
Okay, so as far as I'm concerned, there is a huge amount of work that still remains to be done. There are many aspects of the sampling process that we don't have a firm grip on. And I'm thinking specifically, say, of things like the liberation factor. I mean, there's been a huge amount of work done by Dominique Francois Bongasson, and he's done excellent work. But it's something still that we're not really, we don't model it well. So we're not really understanding the models of the liberation factor very well. So that's one of the things that's certainly one of the areas. And of course, that's only just a small factor in the whole Gies equation. And so I really feel that at least we've created in the world conferences of sampling and blending, of which the 11th one will be held in South Africa next year, we've created a space where people can come and discuss and listen. And I think the scope of those that are involved is growing on a yearly basis. So every time we run this course, we're getting more people from different sectors involved. So one of the things that has been obviously involved over the years is the grain, sampling of grain and foodstuffs and that sort of thing at these various ports. And there are lots of people that have done good work. But now we're moving into Africa, and the Africa constituent is also really interested in what's happening there. So it's like a growing a field, I think.
Is it because a lot of people coming into the space have the same questions and they're all looking for the same answers, or is there actually an actual shift in gears in terms of that solution finding? Because again, and I'm probably not asking the right question here, so take this where you think it should go, but is the answer to this, is this coming from the mathematical modeling side? Or, I mean, it's obviously not G's original experimental approach to solve, quote unquote, this. Wherein lies the answer? What kind of work do we need to do to unravel some of this? Because as I understand it, we're still grappling with quite fundamental components of this sampling problem, right?
Yeah, what you say is quite correct. We are grappling with some of the fundamental issues and questions, but I think people. For example, just one of the examples that I have is like the old heterogeneity test. So let's talk about that a bit.
Yeah, sure.
And I introduced a system where I was screening out different size fractions from, say, 300 kilograms of ore, and I was screening out the different size fractions and then analyzing each of those size fractions for their variability and their mean grade and so on. And I found that quite a useful and quite a valuable way of just understanding the heterogeneity. Now, some others have said, no, it's not necessary. It's too much. It's too detailed. But
Mm,
there are issues in regard to the bulk commodities, particularly iron
mm,
ore, manganese, vanadium, chromite, that sort of thing, where the heterogeneity, these detailed heterogeneity tests are showing up issues that you would never find if you just plotted 1 or 2 points on a and try to regress a straight line through them. So to me, the heterogeneity tests are still really important because we don't you see, one of the problems is that we think we understand our materials correctly, and very often we don't. I think the heterogeneity test is just one step forward in making sure that we do understand those materials correctly. Yeah.
well, so that's
Sorry, can
really
I just
interesting.
say this? Can I just say this also, Rene? Minerals are distributed in nature in as negatively skewed distributions. So that's generally the bulk commodities: iron, chromite, manganese, vanadium, and that sort of thing. So they're negatively skewed. Then you get the normally distributed minerals. Things like coal is a good example. And then obviously the log normally distributed materials, all the base metals and the precious metals. And sometimes I think we just um, charge into these kinds of situations, sampling situations, without really taking the cognizance of the factors that are important in sampling minerals with these different types of distributions. So to me, that's like a really important issue. Yeah.
Well, so can I try and unpack that a little bit, because maybe I'll summarize it back to you in slightly different wording to see how how you feel about this, because I agree with what you said there. I mean, I see heterogeneity tests not as a silver bullet, but as a test of which you will likely learn some stuff, right? And
Yes.
and 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 I think a lot of this work with exploration and sampling is learning about particularly
Yeah.
variance, right? And the more you learn about where it comes from, the better you can solve your problems, and the better your resource models will become. So I position these heterogeneity tests not as you must buy this test and it will solve all your problems, because I've
No, no, no.
tried that twice and that didn't quite work, and I'll come back to
No.
that. And I'm sure you've tried it more than once.
Yeah.
But so, and when you do that, and I talked to Ben Cook the other day, who works for ALS, and you probably know him. He works for the geochemistry in the geochemistry department, and I said, how many people just tick the box 1 kilogram, 2 millimeters, 200 grams at 75 microns without even considering what impact the crushing and the pulverization and the split sizes have on your variance, right? And not
Yeah.
that there is a perfect answer to that, because the 10% G safety line is just another line, right? Why not the 12% Minnitt line, right? I don't know. I mean, so these tests, they are obviously as weak as they are because of the original sample that you collect. So if you're sitting in a gold ore, a 40 kilogram bulk sample is really as hit and miss as you'll ever get it in terms of being representative of your ore.
Yes.
So there are certainly pros and cons to this that people need to be aware of. So far, so good. I see you nodding. You're
Yeah. Yeah.
okay
No.
with it. So so your K experimental determination of K and alpha, and we've talked about this before, right? I quite
Yeah.
like that paper because you work through in detail how the fundamental sampling error formula works, and how you can break it down and reverse engineer your K and alpha and the liberation factor. Beautiful, simple, right? And I find it really, so thanks for that. I think it's a real service to the industry. And
Okay.
I take that paper everywhere just to show how it works. Not this is the solution, but just last week, another team that I was talking to, hey, look, run this exercise with a team, and you'll probably
Yeah.
learn a whole bunch of things about GSEs that you would otherwise never know. But
Mm.
maybe to get to my question, you've changed that approach, because as you and I conversed, 4 points on the line good luck with that one. The moment in gold, one of those samples is slightly out, and somebody somewhere in the lab, somewhere in the preparation, and a little thing flicked in that sample and not in the other, boom, game over, right? And then the regression is a mystery to us all, and then you end up with just accepting one as an alpha for your alpha, and on you go. You move to this new approach by segregating these various components. And I'm probably not getting the theory of this right, but wasn't the counter argument that took away from the theoretical perspective that those particles should all interact but within those bins? Now you've actually separated the material out within the bins. And I thought the original formula or the theorem involved all these different particles interacting with each other. And again, I'm probably getting that all wrong, but what were the counter arguments against that paper? Because I saw that you had good results with it, and I don't know what lies beyond there and who's done whatever else following that. Is that still what you recommend? Sorry, there's a lot there, but these are the things that keep me up at night sometimes.
No, one of the things I did was using manganese ores. I followed the extensive separation of the different fragment sizes and then plotted up the calibration curve. And there was a definite kink in the curve. Now, that was something that I had never seen before. I've never seen a kink in there. How does a kink all of a sudden appear in these calibration curves below a certain size, below a certain fragment size? And as I looked at the ore itself, and I'm still not 100% sure about this because we need to do some additional work on it. As I looked at the ore itself, you can see the crystal structure at about that fragment size, 0.9 centimeters, so 9 millimeters. You start to break down the actual crystal structure of the individual crystals themselves. And I think that's why we're looking at some sort of a kink in this calibration curve. Otherwise, I'm not sure how to explain it. It's still there. And, so all I'm saying too, Rene, is that we do this work. We do this work in good faith, and sometimes they're not clear answers.
Yeah,
There's
science, right?
Sometimes you've just got to accept that things are not going to work out precisely the way you would like it to work out.
Yeah.
So, but you do your best.
Well, no, that's it, and you do your best. And the point is, you put it out, and then at least you expose yourself to others commenting on it, and then coming up with better ideas. Again, that's how science works, right? So if nobody tries, then we'll never get out of this. And that's what I find interesting, and that's perhaps where some of my comments in that previous conversation perhaps were misinterpreted a little bit, because where I was trying to take that line of reasoning is that I've been to these conferences before, and they are all the same people on the same stage every year. And that's not how you solve problems. And it's no disrespect to the people on the stage, smart people doing a lot of good work. But, we know from other industries that the most immediate, that's not the right phrasing, inventions come by different people from outside thinking, well, how about trying this? They come up with a completely different way coming from an outside perspective. Who are the people coming to these conferences, and not, and maybe they're the people from the food industries? Who are you seeing in this field? Right? Because you know everybody in this game. Who is new on the stage, and who should we watch and follow? Who are the interesting young modelers or whatever else there might be who are changing this industry? Who should we add to our LinkedIn friends, I would say?
Okay. All right. So that's a really good question, because myself and a gentleman called Terence and Corsi from Rand Refinery are the two chairmen of the organizing committee for the World Conference Sampling and Blending that's to be held next year. And one of the things that we really wanted to get away from was the traditional kind of lineup of speakers as bringing keynote addresses. So we looked at all the new young people that we felt could and make a contribution and add some good information to these conferences, and we've selected them. Not all of them have been informed so far, so I don't want to mention names, but there are lots of people out there doing good, solid work, really good stuff. And so we're hoping that this time round, Francis Pitard is not going to be on this as not he'll be there, but not as a keynote speaker. Neither Dominique, neither Kim, neither Pentti Minkinen, neither Jeff Lyman. So none of these people are going to be keynote speakers. We're trying to ensure and encourage the younger people, a younger cohort of interested people that are interested in sampling and making a good contribution. Obviously, we have to consider what their contribution has been, but we're trying to get those people to bring keynote addresses to the conference.
And are they, and maybe to pursue that line a little bit further, are you also looking at the controversial nature of their ideas, or are you just looking at contributions, in terms of the work that they're doing, following fairly conventional workflows? Is there something you can capture in their contributions there that has that?
Okay. So look, there are some people with maybe controversial ideas and so on, but we have a very good scientific committee that will review papers and go through them and look at them carefully. And if there is something that is really off the wall, then the reviewers will take it back to the author and ask him about it. And I think the important thing is that it's not just written off. The World Conference Sampling and Blending is not just a forum where we want to present everything perfectly. Let the man get up on the stage, let him present his work, and let the audience speak. They will soon come back to you and say, this is not right. This is certainly not going to work.
That's what conferences should be like, right? And I'm not sure if you followed the Mineral Resource Estimation Conference from last week, but we really tried to get more time for authors to answer questions and for people to sit on stage to debate these kind of ideas instead of the back-to-back, papers with death by PowerPoint. So that's certainly interesting to hear you bring the same kind of philosophy to the end. Look, now I'm coughing, sorry as well. And it's interesting because obviously Galileo had something to say about, the Earth being the center of, things, and people, the establishment wasn't too happy with that. And you've got to indeed try to be a little bit creative, but not allowing the loonies to come in as well at the same time. So, it's a tough gig, but that's really interesting to hear. To those listening, I've got every intention of coming, but if calendar allows, but looks like sounds like a great event in the making.
Well, we're looking forward to it. It's and the progress is good. We seem to be progressing with the organization, so I'm very happy with it.
Okay. Now, look, that's great to hear. And so maybe just staying on a couple of technical notes, because I think for the audience, or like I'm pretending myself, I'm interested in these practical applications of the work that we do. Right? I mean.
Yes.
You go to site, you do a heterogeneity study, and having done some, you know the pros and the cons, so you know that you'll learn some stuff and all those kind of things, right? But there's some other examples, and I saw a paper that you did. I don't know if it was with Simon Dominy, but and I love Simon for his really practical work. He's got the same questions, and perhaps a bit like yourself, he says, "Well, I need to figure out how this works, and then turn it into a paper." And the industry needs that, his underground sampling. But in this particular case, it's that old chestnut of the grouping and segregation era at the lab, right? The amount of times that you do this freaking audit and you're standing there arguing with a laboratory manager about the grouping and segregation era in that pulp. We've all been there. We stand there, and there's no piece of paper with the evidence of, if you do this, then you'll lose this much money, or there is this much variance added, it's difficult to have that conversation. The only thing you can rely on is, trust me, I know how this works, which is not a great argument. Now, you've come up with this paper and you probably explain it better, but a lot of laboratories still, even the large brands, right, all the 3-letter brands, when it gets to the pulp, there is a mat, and there's the 200 grams lying on the mat, and the corners go towards each other, and then the curved brown paper bag comes out, and it scoops right through only once, right? Not 10 increments, right? Not that whole thing.
Yes.
A curved bag, once through it for X amount of grams, and now run us through what you've done in that paper and what the outcomes are for the exploration geologists who probably not look at this kind of stuff often. Does this stuff matter? Should we let these people in peace, leave these people in peace, or should we make a point out of this next time we're in the lab? And this is gold, right? We're talking about now.
Okay.
Save us.
All right. So there are two issues here. The first is the grouping and segregation error. And my feeling is that we still do... Look, I know that a lot has been written about the grouping and segregation error, and there's Piaget's equations about the grouping and segregation error, but I still do not feel that we have got a good grasp of the factors in that equation that Guy produced. And one of the things that I must say is that there is a huge amount of work that has been done on particulate materials that we maybe need to start looking at in some detail, particularly where the density of the target analyte is different to the matrix in which it occurs. So what I did, you go to many laboratories, and I've seen it at least 5 or 6 times, where the lab assistant, he's got a pile of powder on a sheet, and he starts flicking it from corner to corner, and then he'll take the other 2 corners. And I've watched them do it, and then I've said to myself, you know what? The word out in the field is that this is a terrible method, and that it induces segregation and grouping.
Yes.
So and yet they still can't seem to use it. They're still using it. So I thought,
that's exactly what I was talking about.
That what I will do is I will get my own materials and I will put them together. And fortunately, at WITS, we've got a thing called a tomograph, which is a way of looking through a sample and identifying the target analyte. And I did exactly the same experiments. And so what am I looking for in this experiment? I'm looking for the development of grouping and segregation. And I repeated the exercise about 3 times. And again and again, there was no grouping and segregation. And I was using little gold particles, probably down at, let me just get this right, about 100 microns or less. So there were 310 of these little gold grains, and I was flicking them backwards and forwards. Okay, the question is now, how do you get that into into the tomograph without disturbing the distribution of the little gold grains in the material? So I bought one of these food vacuum processor machines, and very carefully slipped it into this vacuum processor. And of course, it sucks all the air out, but maintains the distribution of the grains in the material itself. Then put that in the tomograph and said, okay, let's see, where's the segregation? And there is none. There is absolutely no segregation at all. So that then I thought, wow, okay, this is really unusual. Okay. So, but that's where we are with that. The next step, however, is to take that material, take that portion of the sample and you've now got to split it into a 50-gram aliquots. And the only way that you can do that in a reliable manner is to put it through either a desktop riffle splitter. Oliver Ingemel's had a riffle design that is not well popularized, but it was very clever. Or you can use a rotary splitter, a desktop rotary splitter. But that is the only way that you can ensure that you're getting an unbiased sample out of that.
So can I just confirm, when you say that, so you've obviously, you can only say that when you've actually done the test to compare the outcomes of using either a rounded scoop or a square scoop, because, you know, that's also in the literature, that the design of the scoop needs to be appropriate for the material sampled. So you've done that and you've compared it to both a riffle splitter and a rotary split sample, because otherwise we're still in assumption land, right? Because I completely understand the GSE might not, grouping segregation error might not be there, but then you still have to prove that it isn't induced from that actual splitting process at that point in time. How did you prove that?
Exactly. That's exactly what it is. And the only way that you can, with any confidence, reduce the mass or split off that 20, 30, or 50-gram aliquot in a unbiased fashion without the errors that can creep in from grouping and segregation is to use a riffle splitter or a rotary splitter or the Ingemel splitter. It's a lab-based type splitter that also works well.
I accept that that's the likely outcome, but how did you prove that is the only way? That's what I want to know, because I've been kind of chasing this for a while myself, and because I stand there doing the audits, needing to say something about it, putting the old green tick in the box. And you know, and so many times lab managers, probably by the sounds of it, rightfully say, look, the material is homogenized enough. I don't need to put this through as such and such. But those are two different problems to solve, right? I mean, if it's already grouped and segregated, then however then you split it becomes irrelevant, because it's already going to be biased, right? So if it is properly homogenized, I'll still use inverted commas just for now, accepting that what you found is what you found. How did you prove that it matters how you split that? How did you prove that quantitatively?
Okay, so I took, there is a thing called the rice experiment, and this was introduced by Dominique Francois Bongasson as early as the early 90s, when he had just finished his work with International Nickel Company. A friend of his suggested that he use rice as a matrix, and then he added colored rice grains to that. And then in addition to that, he added a little bits of steel about the same length as a rice grain and the same diameter. So you take a coat hanger and just cut it up into short lengths, add it to the mix, and then perform your necessary experiments. I took that one step further and I said, okay, let's not only do it for rice, but let's do it for popcorn mealies, and let's do it for a dolomite sand as well. And then we'll add materials of different densities. So I added steel, I added lead, and I added tungsten carbide fragments to this mixture, and then performed the experiment by just doing shoveling or scooping, and calculated the coefficient of variation. And then I took a riffle splitter, the lowly riffle splitter, and I put these materials through the riffle splitter. And there is no doubt in my mind that the riffle splitter removes a large proportion of the grouping and segregation error. How much is actually left is difficult to say, but and it would be a residual amount.
Yeah, so hold on. This is interesting because you say now it would even deal with a certain amount of grouping and segregation error, right? So that's even more interesting because I'm still splitting out the fact that you've now been able to prove that there is in fact no GSE if you do this corners, whatever that process is called. It's not
Yeah.
it's not quartering, I guess, but that process. You've proven
Yes.
through this tomography that there is no grouping and segregation error. Um, and so that's a good place to start. And then we move to the splitting component where you said, okay, you could still split it wrong and then by the splitting device itself introduce an
Exactly.
error, right? So we acknowledge
Exactly.
that. You went back to Bongrasson's experiment and you would repeat the same exercise and you would take your duplicates or triplicates or whatever and you would calculate your coefficient of variation for the different materials. And what you're saying is that has actually demonstrated the difference in CVs depending on the different splitting methods. And on top
Yes.
of that, you can even see that the riffle splitter actually removes some of that GSE as well. Um,
Absolutely.
okay.
Absolutely.
And I remember Kim talking about this in one of his papers. And again, I might be connecting the wrong dots here as well, but it's still, there are still people out there, and maybe something for you to comment on, the riffle splitter versus the cone splitter. Some people swear by the riffle splitter if properly designed, and there's too many videos online. And I know Mark Murphy is a fan of collecting all those wonderful videos and putting them on the sampling theory group. But what's your take, having listened to this? So the only way to sample something is a fallen stream if it's a broken ore, so to do it correctly, which is the fundamentals of a plant, I guess, and how you sample and if it isn't sampler and so on. So both a cone splitter and a riffle would work, but what would be the difference in your mind? And did that experiment conclude that riffle, if well designed, is the best way to split?
Okay. So, yeah, there's quite a lot there.
Sorry, yeah.
So one of the things I encourage people to do is to make sure that next to every drill rig, especially if they drilling blast holes, is to put a large riffle splitter there, because very often they will use complex kind of cross methods to try and take a reasonably representative sample from a cone of cuttings that are blown out of the hole in either a blast hole or maybe even a reverse circulation hole, or there's some sort of a cone of cuttings that develops around that hole. My feeling is, why fiddle about with those types of sophisticated looking sampling techniques? Just put the whole lot through a riffle splitter. It's not that difficult. It's probably a bit more labor intensive, but you know what? You're going to get a better sample. Yeah.
Well, that is, yeah, I'd probably argue with that because, I mean, Francis did a lot of work on this, right? And his PhD thesis that I remember
Mm,
was part of the course that we both attended these 14 years
mm,
ago,
mm,
or, I
mm.
mean, you were probably just, not attending in the same capacity I was, obviously, but, you've got the over drill, the under drill, the different
Oh, yeah.
recovery from the different parts of the layers that you drill through, the contamination, and then the fact if you've got a large riffle splitter, the problem with RC drill rigs or blast hole rigs and large riffle splitters, if you have a riffle splitter, right, and then you need to put a whole huge sample through, then you need to split it not once but twice but thrice and so on, and then at that
Yeah.
point in time you're rehandling samples, so every time you do
Yeah.
that you're probably introducing errors. It is quite manual, and then on top of that,
Yeah.
you can't
Yeah.
actually take duplicates of every stage, so you can't actually understand the variability at that stage as well, because you can't, like at a cone splitter, at least you can hang two bags of there, you get your duplicate, and that's probably as real to an actual duplicate.
Mm.
I mean, we're getting a little bit lost in practical detail, but I think Blasel, we should probably not look at that for the actual poor quality sample that you get out of the hole to begin with. So what you do to
Yeah.
it then, I've seen all the papers, but yeah, I'm not sure if there's anything to
Yeah.
improve at that point.
Can I just say, Rene? Lots of people are faced with, like one of the lab procedures that people use is to take a pile of material from which they want to take an aliquot and then spread it out and then divide it into squares. And there's a thing called, it's called the Japanese slab cake. Where on earth they get a name like that from, I do not know, but that's what it's
Never heard of
called.
it.
And then they will take a little spatula, and in each of those little squares, they will select a certain portion of material and they will add it until they reach the mass that the aliquot requires.
Yeah,
Okay,
yeah,
that to me is just like, well, it's as good as a grab sampling in a sense. We've spoken now about the riffle sampling.
yeah.
And then I've had people on courses that I give, and they say, you know what? There's no way that our company is going to spend that kind of money to introduce a cross-stream splitter and all this kind of thing. At the end of the day, what can you say to them except you do the best with what you've got? I know it sounds a bit, but what else can you do?
Yeah,
Yeah.
look, that's really the question, and the whole reason we're probably still in this, having these discussions in the first place and having these conferences, because if we can't demonstrate that, and obviously people like Francis have devoted their careers to try and identify the actual dollar value lost in inappropriate sampling, right? He's got some
Yes.
key
Yes.
papers out on that. So
Yes.
that's fundamental. And the question to answer here is, I mean, everything has to be looked at from the perspective of variance and bias, right? And
Absolutely.
if we accept that bias is never good, keep it really simple, there's more to that as well. This is coming down to how much variance, how much additional variance are you introducing by this technique, and is the additional variance that you introduce, which you have to quantify with a number and not with arm waving. Right? If you say your analytic or your pulp split precision is now 12%, and it could have been 9%, now you've got something, right? Now you can
Yeah.
actually reverse engineer that back into the variance that you end up in your blocks, and you do a lot of work in this space as well. And now we can have a conversation. And what you'll see is the variance that you introduce at that part of the splitting and crushing is pales insignificant to the variance that you introduce by drilling a blast hole in the first place, right? So, to my mind, and having worked in this space long enough to get a little bit of a feel for where the balance of value sits, spending 50,000, well, 5,000 is not 50, $5,000 on a benchtop rotary splitter, that's not a real cost. You know that a fire assay is super marginal and super competitive, and every 10 cents per sample on these mines that put hundreds of thousands of samples through makes a real difference to the bottom line. So if those guys have to spend 15 seconds longer pressing two buttons and putting a bag out and mucking around with a rotary benchtop splitter, that's cost for them, right? So they go straight back to the bag and the scoop and get done with it, because it's all time is money. So it's for us to identify the actual variance that you gain or I guess restrict by doing it properly, and how that actually carries through to your overall sample and then into your blocks. I mean, and there's still not enough out there to really capture that value proposition, I guess.
Okay, so I'm not really. I mean, what you're saying is absolutely correct. That the error and problems introduced in sampling occurred primarily during the primary sampling. So yes, what you say about the sub drill and the over drill in in a mining bench is absolutely correct, and we do find those errors. But again, how are we going to resolve that? That's more like a thing of technology. If you could stop the drill at exactly the right height, you might get a bench floor that is much closer to the level that it should be. But one of the big things with the sub drill is they want to break that rock up because of
there's
the
a reason
tires.
for that. Yes.
Yeah, the tires on the vehicles that they use moving the material are, as I understand it, much more badly affected if there is no subdrill and no layer of fragmented rock.
Yeah. Now look, and we can leave this, but yeah, no, look, there is a reason, and obviously we've hit on one of those wicked problems that where the solution will probably never be easy to capture in words, because the answer is always it depends, right? It depends on what you're trying to do and how important it is. I mean, I spoke to Ben about this last week, and I'm not sure if this will air before Ben's one, but it doesn't matter for those who are listening. But you know, you can get far more accurate analytical techniques as well for your gold, but you're just going to have to pay for it, right? So if you, and he made the point as well, if you want that level of precision, then you can pay for it. And instead of, you know, $13 per fire assay or wherever the hell it sits at the moment, you might pay $14.50 per fire assay, if that's indeed important to you. It's the same reason why you might go for a 50-gram fire assay, or why I've worked with 100-gram fire assays as well. It's just an extra pot in the furnace, double the money, right? But yeah, if you get double the precision, if that's important to you.
The thing is that you've got to be very careful about just doubling the mass of the aliquot you use, because it seriously affects the nature of the fusion that takes place in the furnace. And if you haven't got a good fusion, you are never going to get a good result. So you need to be very cautious about the way you simply increase the sample mass to the furnace.
Yeah, look, and we talked about fluxing issues as well, which drags us into a whole new different space, which is maybe for another time. But look, I find these topics fascinating because they obviously keep coming back. And so next, let's just try to dissolve this into a one-liner. So next time the two resource consultants listening to this podcast, you know, stand there in the laboratories doing their audit, they get to the pulp station, what do they say? So I'm hearing, look, yes, the grouping and segregation error that through this process of quartering is not great, but if you split it with the brown paper bag, you will introduce variance that you wouldn't get if you use either a small riffle splitter or a micro rotary bench splitter. But you need to determine how much variance means to you in order for that to become important or not important. Would that be, does that sound reasonable?
I mean, that is exactly true. And what amazes me is that the laboratories have all the equipment, they have all the resources, and yet they don't do any of that kind of research, because they are in a position better to research that problem than anybody from the outside. So they've got the materials, they've got the equipment. You know, just do the research. Just take 30 samples and you know,
do the calculations.
Use different methods.
Well, that comes down to this comment in Miller and Miller. I'm not sure if you have that book, but you know, it's probably a little bit outside my space, but on geochemistry and analytical laboratories and quality control in laboratories. And there's this beautiful throwaway comment in there saying that, you know, most of the laboratory managers don't quite get the basic concepts about statistical processes and quality control. I mean, they're chemists and not trained in statistics and process control. So you do have to design, and this will lead me into the next segue, but you do have to design the right test to get the right answers, because I did order the lab last year in Africa, and it was, you know, a big brand name. They're doing everything right according to their usual SOPs. It's all the same across the world and all the labs, right? Nothing to see here. But then you get to exactly this situation, and they had done the test work. And that was interesting, because what was there sitting on the bench, shining in all brightness, a rotary benchtop splitter. And I was like, bugger me, I finally found one. And I was really happy. And I said, but it looks a bit lonely. We stopped using it. I said, okay, interesting. Why? Well, we tested it and the results were inconclusive. And because it takes more time, we went back to the scooping with the brown paper bag. And I thought that was fascinating. So there's not necessarily anything wrong with it, because again, everybody does that. But then you look into the testing details and you think, okay, there's a few things that I probably would have designed differently to get the right answers. And that's kind of difficult to do if you don't know how to test this stuff, which is probably for another day. But fascinating. Hey, look, so maybe tell me about the work with Scott Automation that you've been doing, because that actually sort of led
Okay.
to us reconnecting a bit
Yeah,
here.
that
What's that all
was
about?
a really interesting work. So they have the Rock Labs crusher and rotary splitter, and it's a smart rotary splitter so that the amount of material split is pre-programmed, and the mass of the sample is also pre-programmed, so that as they feed the material through their crusher, this smart void, as they call it, will then split off 350 gram sample into the what do they call it again? The Chrysos sampling jars. So the Chrysos is a really new and advanced technology for analysis, and you want to make sure that you're feeding it with samples that are uh, carefully split and carefully prepared. So the aim of the exercise was there were a number of aims in this exercise. The first was to see what the crushing rate was. So how many kilograms per minute or seconds are we crushing through the Boyd crusher? And of course, it has to be at a specific particle size distribution. We know that it's got to be 75% at minus passing at minus 2 millimeters. So those were the specifications on the crusher, and we wanted to see how long it was taking to crush various masses of material. And we were able to get some very nice looking results, some good straight lines on calibration curves and so on. And then the other issue was to actually investigate the accuracy of the split of the materials to two duplicate pots. So we've got two of these. What do they call it? Yes, the Chrysos sample jars. We've got one on either side, and we wanted to just look at how accurate the splitting was. So they've got a linear splitter. It's so it runs in a linear fashion rather than in a rotary fashion, and it has proved itself to be absolutely amazing at the accuracy with which it is able to split the materials into the two jars, into the two sample jars. And it was very good for us. Yeah.
Well, I mean, I did have the Chrysos guys, or Chrysos, still don't know how you pronounce it, on the podcast as well a few months ago. So
Yes,
definitely,
yes.
aware of the technology, and I guess the aim for them is to identify the actual analytical precision and the preparation precision, and really see where the value is, because they can zap the same sample twice. They can obviously take duplicate readings of the same jar, but they can also take readings of two jars that are created as equal duplicates. But then, you run exactly into that problem. If you got a jar and you need to fill it up with 300 grams exactly, then you can't just keep pouring it in there until it's full and then put the cap on, because then that's what a lot of people were doing. And when we were auditing these labs earlier on, we were thinking, guys, fantastic that you got this beautiful new process of analytical, greatness for your gold, but if you are doing that to your preparation, you're still introducing a lot of variance. So it's good to see that work being done. And incidentally, because I've done work on Rock Labs rotary crushers as well as linear crushers, and I found that the standard models, and look, I should probably put a wee disclaimer out there. I mean, this is not a peer-reviewed study, and it's probably more anecdotal, but I've seen a number of instances where the splits are far from equal coming out of those conventional Boyd linear rock crushers, to the point where I thought, oh, wow, is there actually a bias between these two splits? Because duplicates get taken in a
Yes.
conventional fire assay way quite frequently, and there's
Yes.
definitely a variance between those weights as there is
Yes.
in the grains. That's probably
Yes.
quote unquote fit for purpose to get out of gel, but
Yes.
I've always found that interesting. But in this case, this smart board is very accurate, and you've actually proven that with
Yeah.
the test, which is really fascinating. Yeah.
Yeah. Yeah.
Yeah.
Look, this work started as a result of work that I did back in 2018. I decided that I wanted to just do some tests on the rotary splitter that I had purchased from Rock Labs.
Uh-huh.
And I found some really good results. I thought they
Okay.
were very good results. But then I thought, well, I wonder what the manufacturer's specifications for this
Uh-huh.
are. And when I contacted them, they said no, they didn't have any specifications in that regard, but were very interested in developing such. And this is how this work that I was involved in originated. This is where it arose from. I met the folk from Scott Automation in Beijing when we had the 9th World Conference of Sampling and Blending. And they then initiated the process. And at the end of 2022, they invited me to go to Australia and just work my way through the various tests, which I did. Yeah. And the results were, to me, the splitting results were outstanding.
Yeah.
They really
Well,
are, and it really does a good job.
okay. So I couldn't find a paper of yours. Maybe I didn't look well enough. But do you have that in published literature? Because I'd love to put a link in this video for people to look it up. Because I have done some tests, and I've also been on the phone with these guys to get specs for what to expect from the splits to compare it with, and indeed got a
Yeah,
very simple percentage number that without any certificates or forms, like
yeah,
this is sort of roughly what we're expecting,
yeah,
which indeed I found interesting, is that surely there's got to be an expected variance in these weights that has a tolerance level like any set of scales would do as well, right?
right,
But
right.
apparently it doesn't. So that's interesting. But now, can you just clarify the work that you've done? Is that just on the new Boyd Smart, or is it also on the conventional Boyd linear and rotary rock crushers combos?
Okay, so we are going to revisit the work on the rotary splitters.
Yeah.
It's got a sort of a split window, and it's got an adjustable screw on the top, and you can turn the one cone inside the other so that you can either get a 5, 10, 15, 20, 25% split.
Yeah.
So we're going to revisit that work, but the Boyd the linear splitter as it is at the moment is an outstanding piece of equipment. There's
Yeah.
just no doubt about that.
Yeah.
But
Okay.
nothing has been published as yet because we've only just finished the work. And
Yeah.
in fact,
Right.
I'm going to speak to them this morning about that. Yeah.
All right. Well, look, that's really interesting, and so please keep me up to date. If you have
Yeah.
something coming out, please flick me a copy, and
Yeah.
I will update the
Okay.
description in this video as well for people who are interested in it. Yeah, been really good to talk to you. I mean, like we said, there's probably more rabbit holes to dive into, but maybe we should leave that over a beer in Joburg at some point. But anything else on your mind that you wanted to get off your chest, or?
No, it's just that I don't know. I would just encourage people to, especially people that are working for big companies, to actually do their own in-house research. I just feel that there is so much that could still be done. There is so much that still requires doing. Yeah, I just feel that there's a lot that can be done, a lot that should be done. And when they've done those results and when they've done those tests, bring them to the conference. So
Yeah.
yeah, I'm just trying to encourage people. A bit of a flyer here for the upcoming conference. Bring your results. put them on the stage. Let's hear about it. Yeah.
It sounds like retirement is not quite on the cards just yet, Dick. It's just giving yourself more work. But hey, look, it's been an absolute pleasure talking with you, and hopefully next time in person. But thanks for coming on the show. Really appreciate it.
It's been nice chatting to you again, Rene. And there's still much to talk about, which we will do in due course.
Let's come back to it at some point later. Thanks, Dick. See you later.
Yeah.